them together, you got some multiples, you multiply, you eliminate. Same sign, same coefficient, you would subtract. Same coefficients, opposite signs, you'd add them together. So you would do stuff like this where you would add these two together, you get 2x is 9, x is 4.5. Substitute back in and solve for y. You were finding the ordered pairs where those lines intersected. Well, basically the same exact scenarios, but instead of looking at lines, we're looking at the conics. We're going to look at where a circle could intersect a hyperbola. It does look like a tennis ball. We're also going to add into that maybe the possibility of an ellipse intersecting that as well.
Now it looks like
You know what people have thought this looked like earlier?
A bug, a cartoon character or something.
Zurg.
Yeah, that's it.
Zurg.
What is it?
From Toy Story.
Yeah.
I see it.
That's
It's a cartoon character.
It's a cartoon character. It's Zurg. Zurg, yeah. Gotta defeat Zurg. So you would find, in this case here, how many different spots do they intersect? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 possible intersection points for these. They've also done stuff where it's just an ellipse and a hyperbola. Or a parabola, excuse me. You could have 2 spots. You could have 3 spots. You could have 4. You could have 1. Okay? You could have a circle and ellipse where you have 2, 4, 1. I don't know if I can get 3 out of it. No, I don't think I can get 3 like that. You know, I could get this in here and just have the extra one like that. I think what we're going to be doing is we're going to find the combination of these things to do this. Well, the arithmetic that's involved to doing that, it's okay, Shay. I guarantee you this is the easiest thing we've done all chapter.
There's no.
You want to bet?
I'm just no.
What do you plan in?
What are you going to do here? We're going to find the intersection. We'll start easy. I'm going to start with the intersection of Derek put away his food, and x squared plus y squared is 13, and y equals x plus 1.
Hey, whoever won your battle yesterday?
I think it was law. What I'm doing here is I'm going to find the intersection of these 2 parts. One of them is a line. What is the other one? It's a circle, yeah. So I'm going to find the intersection of a circle and a line. Well, if you think about it, how many possible answers could you come up with here? A circle and a line. 2. I could have 2, or I could have none. So I could have, if you just think about the shapes that you're looking at here, there's a circle. Well, I could have 2 answers, or I could have 1 answer. Or I could have no answers. It's possible. So here's what's going to happen. When you go back into thinking about good old-fashioned algebra stuff, do you already have one variable by itself?
Yeah.
Well, I'm saying yes. Why do those yes?
Now you put it on some cold. Yes.
Oh, because that's no.
This is
This is
X.
Twitter.
This is X.
Yeah,
I,
this is.
and anyway, do I have a variable r by itself?
Yeah.
I do.
Oh, it does.
I've got y by itself. So what I'm going to do here is take where I have y, I have this, and just substitute into here. X squared plus x plus 1 squared is 13. How do you work with jump squared? Yep, boil it out. Don't kill puppies. What's going to happen here? What's going to happen here is that you're going to wind up having to combine like terms and then setting aside equal to 0. In most of these problems, you have to do some very simple factoring. Okay?
Yes, you.
Move some stuff around. 2x squared plus 2x minus 12 is 0. What's your first rule of factoring? GCF. What's the greatest common factor here? 2. Since I'm solving for zeros and I factor out a 2, Does that 2 have any relevance to the rest of the problem?
No.
No. What times what's negative 6? You add together to get 1.
-6.
No.
3, 2.
Which one's positive, which one's negative?
3. Get it?
But you said it with such conviction, like, own it. Sorry, I didn't shoot you down.
Negatives.
Singing 5 and -6. That dirty, so.
So in this case, our 2 possible zeros for x are -3 and +2. Now, this is where things get to be a little bit weird. When we did this with linear stuff, you'd get 1 possible answer for x, you'd substitute in and get your other value for y. Now, since you're dealing with conics, you could have more than 1 possible solution. So that means what you're going to have here are 2 sets of possible ordered pairs. -3 comma something and 2 comma something. Which means in order to figure out what the something is, you're going to go back to the equation. Y is going to equal x plus 1. Well, what's -3 plus 1? What's 2 plus 1? There's your 2 possible solutions.
Oh my God.
Or those are, I'm sorry, those are your solutions for where that line intersects the circle. That line is through the circle.
Is that a key here? Yeah.
Michael.
Again, Jay. And
Yes.
okay. Do I even care what shapes these are? No. I really don't.
No.
No, because am I going to ask you to graph these? No. Are you? No. There's no reason. We're not going to worry about graphing these things. I really don't care. But what I want to do here is I want to figure out the solution sets. And in order to figure out the solution sets, I'm going to have to do some sort of, some moving around, some combinations of these things to eliminate. What's that? Take a look at what we have here, guys. I have x squared plus 4y squared minus 4 is 0. And then I have -2y squared and x plus 2. Exactly. No, you see, you're there. You could go ahead and substitute in for x, but then you'd have to do a lot more other stuff. In this case here, the easiest thing to do is just to multiply that bottom equation by 2 and add it to the top equation. That will eliminate the y squared. Multiply the bottom equation by 2. So you have x squared plus 4y squared minus 4 is 0. Multiply the bottom one, you get -4y squared plus 2x plus 4 is 0. When I add those 2 equations together, notice the y squareds drop out. And the 4 drops out. You wind up with x squared plus 2x is 0. Nope. Factor out an x. What are your possible answers? -2 and 0. So my 2 possible answers here are 0 and -2 for x. So what I'm going to do then is I'm going to use that second equation to figure out what y is going to be. So I know I'm going to have a 0 for x and a -2 for x. So -2y squared plus 0 plus 2 is 0. Moving stuff around, you get y squared is 1. Subtract 2, divide by -2. So what's the square root of 1?
1
And then 1 plus minus.
Very good. So y could be plus or minus 1. This is where it gets a little bit interesting. Yeah. Notice how when I'm at 0, I get 2 possible solutions for y. I can have 0, 1, or 0, -1. Sometimes you have to replicate that x coordinate more than one time. If I use -2 for x, -2y squared minus 2 plus 2 is 0.
Negative
You get -2y squared equals 0, so y is
2.
0. So in this case, you wind up, for that value of x, when it's -2, you have one possible value for y at 0. So these two curves intersected 3 spots. Huh.
I'm cold.
All right. Again, all we're doing here is some version of an elimination problem that you guys have all done in the past to deal with the conic center. Now, I'm not going to lie to you. Some of these things can give you really, really crummy answers because sometimes you might have to use quadratic formula. Sometimes you might get some weird square root solutions. But I've done my best to pick problems out that the numbers should work cleanly. Yeah?
There's a group, so you want to see the smallest one vertical, whatever it is.
What do you mean?
Like you want to simplify it.
Oh, yeah, you simplify it like you would normally, yeah. Yeah, if it's like the square root of 8, you wrote 2. That's like, yeah. What'll happen, guys, what'll happen here is what I've decided to do with these things is the most complex solution-wise, I'm trying to keep them at, are going to be like integers in like halvesies and quarters, simple fractions. I'm going to try to steer clear of some of the really god-awful roots, so you shouldn't have to worry about that. Okay. I'm going to try my best. I went through a whole bunch of these. A lot of them are awful, but I'm trying to pick and choose best I can. Okay. Let's try one more. Do this one on your own. So when you add these two equations together, you get 2x squared minus 16x plus 30 is 0. After that, I'm assuming you factored out the 2. Yes, sir. Well, when we're trying to solve for your possible zeros, it really has no bearing on the problem whatsoever.
I suppose like you have to make it equal to the other side, and then if you factor it out like we did it.
You really don't, because here's what happens, right? You can divide both sides by 2, and it goes away.
Yeah, but in the other one, it was x plus 2, you can make x equal to 0. Like if you factor out an x, then you would make x equal to
Yes, but in this case, I don't have like an x times an x plus 2. I've got 2 binomials there.
So you even though the number doesn't matter.
Right. It is.
Yeah. Well, no. For the other one,
Yeah.
I added them together, but I just factored out the y. Like I took the y out, so that when I got to the y,
Oh, you said like y squared equals x squared minus 9 and just put it up here?
yeah.
Okay, that's basically the same thing we're doing. Because it just so happens that since they're alternating signs, it works out nicely. That it does work that way. Yeah, that's fine. It's perfectly fine. So now what times what's 15? You add together, get -8. -3 and -5. Your possible zeros then are 3 and 5. So I start with my ordered pairs for my solutions of 3 and 5, and I substitute back in. Well, I'm going to use this second equation here, where I have x squared minus 9 will equal y squared. All I did there was just move stuff around. Okay? So 3 squared minus 9 is what? What's the square root of 0? So that one gives me just 0. When I use 5, 5 squared is minus 9 is, square root is
Plus or minus.
also minus 4. So this one gives me 5, 4, and 5, -4. All right? And that's all we're looking at for today.
We will never have to know.
No, because when you're dealing with these things, you're just solving for the intersection points. Okay? Do those, please. All right? This is 10-7, session 10-7. Yes, sir. Yes, sir. You like that what That's why I had on there when x was 3, I had it by order purpose 0. Thank you. Yes, sir. It was pretty I mean, there's a lot going on. But once you got this, once you got your stuff into
You know what
the,
to find everything.
What is the basis?
that's really all it is. Then you get to list out your word pairs, because we don't have to list these word vertex, co-vertex, focus,
He doesn't have
right, so and then you have to see the equations of the asymptotes.
That's